Hello everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. We are into unit number 1 and we are learning about finite automata. So in my previous video we have seen one example where we are able to complete the construction or the designing of Mealy Machine followed by the Mealy Machine. Okay, now we are taking into another example where we will be looking about how to construct a Mealy Machine based on a different language. Okay, and in this language it will be I think much more clear to you all I think because you have already undergone one more example. Okay, so let us check what the language says. We have to construct a Mealy Machine that takes the set of all strings over 0, 1 is the now input alphabet, so that's already I have mentioned over here. Okay, then produces A as output if the input ends with 1, 0. Okay, that means we are having one particularly one new part where we'll be looking into that. If we are having the input string that ends with 1, 0, okay, that will produce, the state will produce the output as A. If the input ends with 1, 1, the output will be B. Okay, and otherwise other states will produce the output as C. So this is the given parameters. Let us check what it actually means. Okay, so I have already mentioned over here as that if the input is 1, 0, that means the string is of the form 1, 0, the output will be A. If it is 1, 1, the output will be B, and otherwise the output will be C. So let us check it out how the diagram will looks like. Okay. Okay, so I have taken 4 states right now. I already know about the particular example, only for making it a little bit faster or making it clear. So I have taken all these 4 states. Now I will do the naming of these states later on, but just we need to focus on the strings first. Initial string will be 1, 0 and 1, 1, that we have to keep in mind. That means we will be starting off with either 1, 0 or 1, 1, correct? That means if we take this transition as 1, okay, definitely this particular, this way we can look into this as 1, 1. Okay, so if the transition is 1, 1, then the output will be what? Output will be B. So definitely this state will comprise the output as B. Okay, now if there is a transition for 1, 0, where I should take, that's why I have taken one more transition, that is for 0. Okay, if it is 0, then this output, this state will produce the output as A. Okay, otherwise it is C. I think it is clear how we have proceed. So let me name the states as well as the outputs. Okay. Okay, now if you look into the scenario, I have named the states as X, Y, Z and N. Okay. Now, as I told you, if the input string is 1, 1, that means 1, 1, the output will be what? Output will be B. It's perfectly working. Okay. If the input string is 1, 0, 1, 0, the output will be what? A. So always first draw with the restriction part, then we will move with all the strings. Okay. And otherwise, what will be the output? Otherwise, it will be C. Okay, so that means if we reach a particular state which is having output C, that means it is a non-final state, and where we'll be reaching the output as A and B, we will encounter those states as final states. Okay, I think it is clear to everyone that how we are naming the particular states. Okay, so now what we'll be doing, we'll be looking into other criteria as well, where we'll be looking into all the states, all the different type of strings. Okay. Now if you look into this part, initial state, definitely it is having only one transition, that is your having transition as 1, correct? This is the initial state, so initial state arrow sign I haven't given, so I have given right now. Okay, so this state X is having a transition for only 1, but it is not having a transition for 0. So what I can do, initially I can start off with 0, so there is no restriction for 0, so I can take a self loop over here. Okay, and this self loop will what? It will explain you the input string as 0. I think it's clear to everyone. Okay, now moving into the next state, that is Y. Y is having for now first I am looking into 1, 0 part. So 1, 0. Okay, so Y is having this transition that is moving towards Z. okay, that is moving towards Z, okay, and it is having only one transition, it is 0, and another transition it is having for 1, so I don't have any problem for the state Y, okay. Now if we look into the state M, M is having a problem because M is having neither any transition for 1 nor for 0. So what I can do, I can take a self loop for 1 because you see it will always accept ending with 1, correct, because 1 means any state which is having output as B. So output as B, that means 1 will always be accepted as a final string. So I can take a self loop from over here and I can name this transition as 1, correct, I can name this transition as 1. Okay, I think it is clear to everyone. Now if I talk about 0, I cannot just take a self loop for 0 because having output B, I cannot have ending as 0, okay. So what I can do, what I can do is that I can take a loop from here and make this transition to this one, okay, and besides taking a date state, I can take a state over to D. Because why I am taking 0 as in this transition, because this state is having output A, and output A can have a end string ending with 0, so that's why I have sent a transition to A. I think it is clear to everyone. Okay, now state M is done with the transition process. Now looking into the last state, that is your state number Z, it is not having a single transition for 0 nor 1. So what I can do for 1, I can take a string and a transition back to Y. Why is it so? Because I can have a input string 1 0 for the output A, correct. So I can take a 1 over here. So if it is a backtrack also, then I don't have problem because the string will be ending with 1 0 only, okay. So that is acceptable. And for 0, I can get a backtrack to this particular state, that is state number X, because this is not having any problem, so I can take a transition for 0. I think it is clear to everyone, where we have completed the process of Mealy Machine, where we have taken the conditions, that is 1 0 1 0 will be having output as A, correct. 1 1 1 1 will always have output as B. Now you can pause the video and you can find out different type of possible strings, and you can check whether this diagram is satisfied or not. I think it will be properly satisfied, okay. So if it is done with Mealy Machine, now it is very easy to understand how to construct a Mealy Machine, correct. So what I can do, I can look into the transition number 1, that is transition number 1 is this self loop for 0, where it is entering into state X, which is having the output as C. That means what I can do, I can do the output will be for this as C, okay. So next, what is the incoming edge? This is another incoming edge, so this is also output will be C, okay. I think it is clear. Then moving into the next state, Y is having one incoming state, two incoming states, okay. So for both the incoming state, both the incoming transitions, the output will be what? Output will be C only. The output will be C, okay. So this is clear, I think so. And then moving to this transition, this is also having the output as C, okay. So this is clear. Now state Y is done. Moving to state number Z, it is having 1 2 incoming edges, and all the output is A. So this will be having an output as A, correct. So output will be A, okay. And for this particular transition, it will also have the output as A, okay. This is, I think, clear to everyone. Okay, now moving to the state number M, it is having 2 incoming edges, 1 and 1, okay. And what is the output? B. So definitely the output will be now, okay. And for this one will also have the output as B, okay. So I think it is clear to everyone, and we are done with the Mealy transitions as well, okay. Now what we need to do, we need to just remove these particular outputs from the states, okay. So I'm done with this, and this is your final Mealy Machine diagram. I think everyone is clear with the process. So we got both the Mealy Machine and Mealy Machine for the diagram, and I think it's almost done with the process of constructing or designing a Mealy machine and Mealy machine. In the next example, we will check it out how to convert a Mealy machine to a Mealy machine and vice versa. Okay, if you're having any queries or any suggestions, you can comment down below. If you're having any other language where you are having a problem in designing a Mealy machine or Mealy machine, you can get a query and we will look into that. So thank you for watching the video. We'll meet in the next video where we'll be coming with the conversion process. Thank you.